For this section, we're going to be using proportions to solve some word problems. So let me start with a motivating example to explain what we're talking about here. So suppose a recipe calls for 1/3 cup of sugar and it serves 4 people. Now suppose we have 21 people. If we want to serve 21 people, how much sugar should we use? Well, to solve this, I'm going to use a proportion ultimately, but what I want you to see first of all is the following. We have, for 4 people, we require 1/3 cup of sugar. So if I can simplify this in the following way, I can do 4 over, well, let's see, 4 divided by 1/3 is the same as 4 over 1 times 3 over 1, which equals 12 over 1. So what this has is 12 people per 1 cup. This is the unit rate. 12 people it takes for 1 cup of sugar. Well, no matter how many people you have, if we want to increase that to 21, we keep this particular ratio or this rate for no matter how many people we have. So if we want 21 people, that means that I would want to change the 12 into 21 people. But I wonder how many cups it's going to take for 21 people instead of 12. So these rates are the same thing. So instead of doing all of this and trying to figure out the rate per person and then trying to manage it for 21 people, we could use a proportion to solve the same thing. So this stuff I'm going to X out. I'm not going to make use of it. Instead, what we're going to do is this. We know that if we look at sugar divided by the number of people, we know that we need 1/3 of a cup for 4 people. However, we're not serving 4 people. Instead, we're serving 21 people. So notice how I set up my fractions here. Sugar is in the numerator of all of these fractions. The number of people is in the denominator of all of these fractions. Since I don't know how much sugar I'm going to need, I'm going to put an X in that spot. Now this is a proportion that you can solve. We could take this 1/3 and multiply it by the 21, and then we can take this 4 and multiply it by the X. So the new equation becomes 1/3 times 21, and you might want to make the 21 over 1 just to make the multiplication simpler. That equals 4x. Then let me do a little simplifying here. 3 goes into 21 7 times. So finally, I can finish this off by dividing by 4. So we get 7/4 is the amount of sugar that we want. So 7/4 7/4 cups of sugar. Now, I don't know about you, but I have never read a recipe that said to use 7/4 cup of sugar. Instead, they'll usually give a mixed number. So for that purpose, I will divide 4 into 7 without going into decimals. 4 goes into 7 once with a remainder of 3. So we really have 1 3/4 cups of sugar. This is what you're going to be needing for the recipe. So that was an example, a classical example involving recipes. What I'm going to do for the rest of the problems is I'm going to grab them out of the textbook and just solve, I don't know how many of them, I just have a bunch of them. So out they come from section 6.5 out of your textbook. And we're going to start with problem number 4. So when I paste it in here, you'll be able to see what problem number it is. These problems come out of 6.5. And let's take a look at it. Remember, all of these problems intend for you to use proportions to solve them. So that's what primarily I'm going to do to solve them, although some of them may require more than one proportion. It just depends on the problem itself. The earlier problems like this one will require nothing special except just a straight up proportion. So let's go ahead and take a look how that works here. We're looking at Pepsi and caffeine. So they tell us 12 ounces of Pepsi and 38 milligrams of caffeine. And then they go, how much caffeine is in 20 ounces of Pepsi? So they give you a new amount of Pepsi, but they don't give you a new amount of caffeine. So when I set up my proportion, I'm going to set up an equation that uses Pepsi on the top and caffeine on the bottom. You could turn yours upside down, it's just so long as you get everything else in the right spots. So when I set up my proportion, the numerators are always going to use Pepsi. How much Pepsi was involved? We're told that 12 ounces gave 38 milligrams of caffeine. So 12 ounces of Pepsi, 38 milligrams of caffeine. Then the question is how much caffeine, so I don't know the amount of caffeine, is in 20 ounces of Pepsi. So I'll put a 20 up here. And from this we should be able to figure it out. So as always, cross multiply. So I get 12x equals 20 times 38 is 760. Let me divide by 12. And let's see what we get. I know that 4 goes into 760 and 12. If I take 760 and divide it by 4, I get 190, and 12 I get 3. So I have 190 over 3. Now it says to round your answer to the nearest whole number. Well, I don't know what my whole number is until I do long division. And whenever they're talking about rounding, it's probably a good idea to go into decimals because that's the easiest way to round. Well, let's take a look and see what happens. 3 goes into 19 6 times. Bring down the 18. 19 minus 18 is 1. Then we bring down a 0. 3 goes into 10 3 times. And then I can bring down a 0 and put my decimal point in the correct spot. 3 goes into 10 3 times again. And you can see that as we bring zeros down, I'm going to keep getting a collection of 3s. So my answer is actually 63.3 with a bar over it milligrams. That there is an exact answer to the problem. However, it says to round to the nearest whole number. So to round, let's take a look. We have 63.3 with a bar over it. The whole number is the 3. That's the unit's value. And if you look at the number behind it, it's a 3, not a 5 or more. So we round down. And we get 63 milligrams of caffeine. So up here, the 63.3 milligrams that I put is not the answer that they were looking for. Although it gives the exact answer, you got to be careful. They said to round the answer to the nearest whole number. So that's why I went and did it only to 63 milligrams in the end. Well, let's go ahead and continue. More problems from the textbook. The next one I'm going to do is problem number 8. So let's see what's in there for problem 8. Right here we have 30 newspapers cost $48, and they want to know how much 8 newspapers are. So I can do my fractions that I set up. I can set up the number of newspapers divided by the cost. Let's do that. So I have 30 newspapers cost $48, and 8 newspapers cost an unknown amount of money. Obviously, since this problem is in dollars and in cost, that's what I'm going to be finding, how much it costs for these. Getting a decimal shouldn't be that big of a deal. We'll just take it to 2 decimal places. So anyways, I will cross multiply. 30x equals 48 times 8. That is 384. And now I'll divide by 30. And as I suggested, it's easiest to write this as a decimal since you're talking about cost. So I'm going to go 30 into 384. And I know I'm going to get a decimal probably, even if it's 0.00 to indicate 0 cents. So let's start here. 30 goes into 38 once. Bring down the 4. 30 goes into 84 twice. And then bring down a 0 that I put on the end. And then 30 goes into 240 8 times. So this is supposed to be dollars and cents. So $12.8. While that is true, that's how much it cost, that's not how much anybody actually says. They'll usually describe the cents in more detail than this. So how do you finish it off then if you just have 12.8? Easy enough. Put a 0 at the end of it, and you get $12.80. Moving on. I'm going to next do number 12. All right, in this problem, we see that 17 out of 20 American youths who play video games, they show addictive behaviors. So they would like to know that in a group of 260, how many would you expect to have this particular addiction? So what we could do is look at the addicted divided by, I guess, the number of youths. That way, when I set up my proportion, I'm going to use the number of addicted on the top and the number of youths in the bottom. So we are told at the beginning that 17 addicted out of 20 youths. And then we want to know if we have 260 youths, how many of them are expected to be addicted. So straightforward cross multiplication. 20x equals. Now 17 times 260 is not one of those numbers that I can do off the top of my head. So I'm going to multiply it out. So I get 2620. I find that hard to believe. I'm going to have to check myself here and see what I did wrong. 7 times 0 gave me the 0. 7 times 6 gave me 42. Oh, I didn't do this multiplication part. 7 times 2 is 14 plus 4 is 18. For some reason, I didn't do that part before. Let me cancel these. It looks like I get 4420. And now I'll go ahead and divide by 20. One of the things you should know is that when you're dividing by things that end in a 0, I can divide both the numerator and denominator by 10 and get this. Next, 2, well, they're both even numbers, so 2 does go into 442. It looks like 221 times. So my answer is 221 youths, I guess. By the way, before I go forward, let me come back and just make sure I put my units on my problems. This last one, the units were dollars and cents. They were there. Milligrams was the first one. So I just want to make sure that in each of these problems I have the correct units that are being to answer completely. All right, let's move on. For this one here, I think I just want to do number 16, but let me grab the picture first of all. This tells us the key to the measurements. And let me make it big. And then let me go ahead and pull in. I was planning on doing just number 16, so let me go ahead and do that. Pull that up as well. Let's see if I can paste it somewhere over here. I don't know if it'll let me paste it onto here. Well, let me move up. What I need from here is that 1 inch represents 4 feet on the plan. So I'll be making use of that because right there is a ratio already, 1 inch to 4 feet. So let's keep that in mind. 1 inch to 4 feet. So, or if you want, 1 inch divided by 4 feet. Let's take a look at number 16. And see what it's asking us. All right, they're talking of the dining area. That area is right here. How big is my dining area? Well, I see that it's 2.25 inches long. Let me write on this. Well, I don't need that actually. I can just write on this thing right here. How wide is it? I have 2.25 inches high, I guess, or long. How wide is it? I need to know that because it wants to know the width and the length. The length I'm going to be able to get. Let me do the length part of it. Now remember, you're setting up the fraction inches to feet, and we saw that 1 inch was equal to 4 feet. So in our picture here, the length is 2.25 inches to an unknown number of feet. So I'll cross multiply. 1x equals 4 times 2.25. 4 times 2.25 is 9. Well, this is easy. We get 9 feet. Now for the width, I need to have how wide it is on this picture. If you look, the total width of the entire house is a total of 5 inches. 1.5 inches plus 3.5 inches. So the total width of the house is 5 inches. That spans from all the way to the right to all the way to the left. Now look at ours here. Ours plus the patio area is the same width as the entire house. The patio area already has 3 inches, so what does it leave left over? It leaves 2 inches for this part. So for the width, remember I'm going to use the same formula, inches to feet. So I was told 1 inch was equal to 4 feet, and our width was 2 inches, and we don't know what its real width is in feet. So cross multiply. 1 times x equals 4 times 2, which is 8. Well, that's just x equals 8, or 8 feet. There's a few more. What I would do if I were you is probably grab some more questions from that picture and see if you can fill in all the information. One thing I wanted to try to do was this next problem here. It gives information about television sets, and I think all I'm going to do is problem number 30. So let me grab that. Let me mark this off and move this up. All right, so what do we have here? We have a new movie theater is being constructed with 4 different screen sizes. Fill in the dimensions, and they tell you that the width to height is in a 16 to 9 ratio. And ours, what they give us the width in feet, which is 40, but we don't know how tall it is. And this, of course, will be in feet. So we'll cross multiply. 16 times x equals 9 times 40. That's 360. And then to find out what x is, I'll divide by 16. So let me go ahead and put the 16 into 360. It does not tell you that you have to answer in decimals or fractions, so you can apparently choose whatever you want. Let's start with 16 goes into 36 twice. Bring down a 0. 16 goes into 40 twice. And now I have my decimal. I'll bring down a 0. I guess I'm going to go into decimals, although you could have done fractions if you wanted. 16 goes into 80 exactly 5 times. So this decimal doesn't go on and on. At least it stops. So the correct answer in this box is 22.5 feet. Next, I'd like to do problem number 30. I'm just trying to grab a little bit of everything in this problem. Oh, there was number 30. Let's move on. Number 36 is my next one. Now, I don't know about lawnmowers anymore, but a lot of smaller appliances that you use outside, like a weed whacker or any of those kind of things, do mix oil and gas together, and in this ratio too, so you have to be prepared for this kind of stuff. You may actually see it in real life. Well, anyways, let's see how it goes here. We are told to mix in a gas to oil ratio. Whenever they tell you this, gas to oil, what they're doing is saying set up gas divided by oil, and that's in a 40-to-1 ratio. Now what you have to deal with is gas goes in the numerator and oil goes in the denominator. So I want how much oil in gallons must be mixed with 2 gallons of gasoline. So I've got my gasoline, and I don't know how much oil, so I'll go ahead and put an X in there. Multiply through, and we get 40x equals 2. So if I divide by x, I can simplify that to write 1 over 20. So my answer is 1 over 20 gallons of gas, 1/20th of a gallon of gas. If you had wanted to, you could have done the decimal for this. I'll let you do this on your own. Or 0.05 gallons of gas. For that, you just have to do long division, 20 going into 1, or 20 going into 1.0. Now there's a second part to this question. If 1 gallon is 128 fluid ounces, how many ounces must be added to the 2 gallons? So we want to change the amount of oil. Oh, I made a mistake too. How much oil? How much oil? This X was in the oil spot. So I want, this is my mistake here, 1/20th gallon of oil, or 0.05 gallon of oil. And now, if 1 gallon is 128 fluid ounces, how many ounces must be added? So what I need to do is to change from gallons to ounces. And for this, we know that 1 gallon is equal to 128 ounces. And so 2 gallons, or what is ours, 1/20th of a gallon actually, 1/20th of a gallon is equal to an unknown number of ounces. So let's go ahead and do my cross multiplying. 1x equals 1/20th, take this whole thing, times the 128. You might find it better to write the 128 over 1, and so then I can do some dividing. I noticed I know a 4 goes into both 20 and 128. 4 goes into 128 32 times, and 4 goes into 25 times. So you could say 32 over 5 ounces, although it's unlikely that that would be accepted for an answer. Either a mixed number or a decimal seems appropriate. So for the mixed number, let me take 5 into 32, and it goes in 6 times with the remainder of 2. So we could say 6 2/5 ounces of oil. Or if you wanted to go decimals, you could have written this as 6.4 ounces of oil. So this was a dual proportion type of a problem. All right, moving on. The next one that I'm targeting is problem number 40. All right, we have sort of a two-part problem here. Not really two parts, but in a way it is. What we have is that 4 out of 5 students eat at a fast food restaurant every Friday after school. So only 1 out of 12 of those students, the ones that actually go, order a healthy menu item at the school. So we have two things here. Out of 3,850 students, how many students will go to a fast food restaurant on Friday and also order a healthy food? So first, I'm going to figure out how many students go to a fast food restaurant. So we're told that that's 4 out of 5 is the standard ratio of students. And so we have, so I don't know how we would call it. I guess we'd say fast food students divided by total students. So let's do fast food students versus the total. And we have 4 fast food students for every 5 students. Now we have a total of 3,850 students, so 3,850. And first of all, I just want to find out how many go to these restaurants. So I will cross multiply. 4 times 3,850 equals 5x. The 4 times 3,850 I'll have to do off to the side. So it looks to me like I have 15,400. Now I'm not quite done yet. I need to figure out what x is, so I'll divide by 5. And 5 goes into 15 3 times. Subtract, I bring down a 4. 5 goes into 4, none. So I'll bring down a 0. 5 goes into 48 times. And then I've still got one spot. Well, 5 goes into whatever zeros are left 0 times. So I have 3,850 3,080 fast food students. So 3080 fast food students. Now, of those, of the people who actually do this, 1 out of 12 students order something healthy. So we now know, for the second part of the question, how many healthy. So for that part of it, we know that we have 1 out of 12 do that. So 1 student out of every 12 students orders healthy. We have, in our problem here, we have 3,080 students, and we would like to know how many of them eat healthy. So we could do healthy, this is my setup here, versus total students. Well, actually, I shouldn't say total students. I should say fast food students. And let's go ahead and multiply it out. 1 times 3080, 12x. In order to figure out what the x is, I'm going to divide by 12 on both sides. So let me take the 12 into 3080. Now notice, before I go further, I wanted to mention one thing. Look what it says here. Round to the nearest whole number. What that tells me, it's probably best to do this in terms of decimals, because that's the easiest for rounding. So I'm going to anticipate that and put a dot for my decimal point, waiting for me for when I get there. So let's start. 12 goes into 30 twice. 30 minus 24 is 6. Bring down the 8. 12 goes into 68 5 times. Bring down a 0. 12 goes into 80 6 times. And then I can start bringing down zeros as I'm now past the decimal point. 12 goes into 86 times. And it looks like I'm going to get this forever and ever. The 6's will just go on and on. So I know that my answer, the exact version of the answer, is 256.6 with a bar over it. Unfortunately, there's no such thing as 0.6 with a bar over it of a person. So I need to round. So round to the nearest whole number. This will be the final aspect of this problem. So when I do this, I look at my 256.6 with a bar over it, and the digit I'm interested in rounding to is the one that's circled. The one after it is more than 5, so you round up. So what do we get? 257 students. Order healthy. So hopefully that will give you a good combination of problems in order to set up your proportions. The next thing I would like to do is move on to section 8.1. And in here, we're going to start looking between connections between percents, fractions, and decimals. So one thing probably that we need are the basic numbers. I don't know if I call it basic relations, I guess. Let's start. 1% is the same as 1 over 100. Percent literally means per 100. or as a decimal, we could write that as 0.01. On the other hand, we have this. 100% is equal to 1. These are the two items that we'll need the most throughout, because these are going to be the things that help us convert. Let's start right off the bat with this problem. Convert 43% to a decimal and a fraction. All right, for this then, let's start with the decimal. Remember that 1% equals 0.01. So that's conversion from a percent to a decimal. So for the decimal conversion, I'll do this. I will do 43% is the same as 43 times 1%. So I just stripped off the percentage. And since I'm going to decimals, this is 43 times 0.01. Well, all that 0.01 tells you to do is move the decimal to the left 2 places. So I get 0.43 is the decimal version of the answer. Now as a fraction, I'm going to use 1% equals 1 over 100. So this time, when I have 43%, this is 43 times 1 over 100. And if it makes you feel better, put a 1 under the 43, and you'll get 43 over 100. And so there you go. This thing has been changed to a decimal and a fraction. With this said, it is unlikely that you will do all this stuff. Most students like the idea of taking the percent and simply saying move the decimal 2 places and you get this decimal. Once you have the decimal, it's not hard to get the fraction, because if you think of 0.43 as 43 hundredths, if you actually say it in longhand, I guess you would say, 43 hundredths, the fraction writes itself. So I'll try to use those ideas as I go forward, because that's mostly what students do end up doing anyways. Let's go to another one. So convert 9% to a decimal and a fraction. So we'll start at the decimal. And think of this as 9 %. As I said, I mentioned move to the left 2 places. And anytime you have a blank spot like that, you need to put the 0 in there. So I'll get 0.09 will be my decimal. And then as a fraction, you have 0.09 literally means 9 hundredths. So the answer there is 9 over 100. And that's all there is. So it's probably, at least as far as students are concerned, it's generally easier to go to the decimal and then get the fraction from that. In fact, decimal form is the easiest form to convert to anything else. Let's do another one. This time, let's convert 13.5% to a decimal and a fraction. So we'll start with the decimal. and you take your 13.5% and you move the decimal to the left twice. And we get 0.135. And for the fraction, remember this 0.135 means 135 thousandths. So you can do this if you know your place value. 135 thousandths means that I have 135 over 1,000. Now the problem itself did not tell me to simplify it, but if you are asked to simplify, if you have to simplify, then here's what I would do. I would start with dividing by 5. 5 goes into 135 27 times, and it goes into 1,000 200 times. So the simplified version of this is 27 over 200. And notice that since the only thing that goes into 27 are 3s and 9s, none of those things go into 200. It's in simplest form. So either one of those should be fine, just depending on what your instructor asks you to do. Let's convert 0.1% to a decimal and a fraction. Start with the decimal. So I'm going to take my 0.1% and I'm going to move to the left 2 places. Notice that's going to pick up an extra 0 after that. I'm going to get 0.001, and I always put a 0 in front for myself. And so that would be the decimal version of it. As a fraction, we have 0.001 equals 1,000th. So 1.001 equals 1 over 1,000. And anytime you have a numerator of 1, well, you know it's simplified. Next, let's convert 400% to a decimal and a fraction. So I'll take my 400 %. This will be my decimal that I'm working on. And I'm going to move to the left 2 places. So I'm just going to get 4.0. I don't care how many zeros you use, but there's your decimal version of it. Fraction. Well, 4.0 is the same as 4 over 1, or if you want just the number 4. So I don't think that they would give you any grief if you put 4.0 down for the fraction, because it is exactly the right answer. Now let's look at some of these fractions. Let's write 90% as a fraction in lowest terms. So here, I like the idea of doing 90% is the same as 90 over 1 times 1 over 100. The 1% is equal to 1 over 100. And then you can simplify this. For example, 10 goes into 100 10 times, 10 goes into 90 9 times, and all you're left with is 9/10. And that's in lowest terms. For my next one, let's write 225% as a fraction in lowest terms. So I'll do the same thing I did. 225% is the same as 225 over 1 times 1 over 100. And now I can start canceling out stuff. I noticed that if you divide 100 by 25, I'll be left with 4. And if I divide 225 by 25, I'll be left with 9. So I'll get 9/4. Now, or if you wanted to, if you were asked to write it as a mixed number, you could write it as 2 1/4. Although the problem didn't ask for a mixed number, it just simply asked for a fraction. So you can convert percentages directly to fractions simply by changing the percentage sign to 1 over 100. All right, let me go back to some of the other types that I was doing. Let me write 17.5% as a fraction and a decimal. Well, decimal and a fraction. See, in a problem like this, I don't think I would use 1 over 100 if I was just to do a fraction, just because of the 0.5 that's already in there. I would definitely want to go to a decimal first. So let's do that part first. So I have 17.5%. I'm going to take this decimal and move it to the left 2 places, and I'm left with 0.175. And then the decimals, as I mentioned, are the easiest things to convert to other stuff. As a fraction, just say 0.175 equals 175 thousandths. That's because the 5 here is in the thousandths location. So this equals 175 over 1,000. Now, if you're asked to simplify, and let's face it, you're always asked to simplify. I'll take my 175 over 1,000, and I'll do like I did before. I'll divide by 25. 25 goes into 1,000 40 times. 25 goes into 175 7 times. If you can't do that big of a jump at once, just do it by 5s and make sure that you get the same answer that I do when you work it. Now we've spent plenty going from percentages. Let's start going some other directions. And you'll see with this next one, I want to write, actually the same thing, write 56.25% as a decimal and a fraction. So we'll start with the decimal. We take our 56.25%, come back 2 places, and I'll have 0.5625. And then for the fraction, instead of writing out like I have been, I'm going to do this, 0.5625. That 5 is in the 10,000ths spot. Since it's that, this decimal equals 5625 divided by 10,000. And then it's just simply a matter of simplifying this type of a problem. I think what I'm going to try to do is I'm going to try to do 25 into 10,000 and 25 into 5625. Since this ends in a 25, I feel pretty good about 25 going into it. So let's say 25 into 5625, how many times? So it looks like when I divide by 25, I'll get 255 in the numerator, and in the denominator, I believe we're going to get 400. So not quite done yet, assuming that it has to be simplified. Keep that in mind. So 255 over 400. At this point, I think I'm just going to divide by 5. So if I divide 5 into that, I'll get 51. And 5 into 400 gives me 80. So I think I get 51 over 80. Is that true? Yes, I think so. Let me check myself to make sure I did get the right answer. 51. I think I did make a mistake here somewhere. Yes, I think I did. I think it may be. What I'm going to do here is let me give myself a little more space in this and just make sure of it. So I'm going to do 25 into 5625. Always give yourself more space if you think you're going to need it. All right, let me start this over again. 25 goes into 56 twice. 56 minus 50 is 6. Bring down the 2. 25 goes into 62 twice. So you get 50. 1, 2, 5. And then it goes into 125 5 times. I think I see where my problem was there. I had 225 over 400. Let's see how this works out. 225 divided by 400. I'm going to do the same thing I did before. I'm going to divide by 25. 25 goes into 225 9 times, and then 25 goes into 400 16 times. And there we go. Instead, if you had not seen the 25, go by 5s. Keep canceling out 5 and canceling out 5 till you arrive eventually at what I have, which is 9 over 16. Next one, actually, it's on the next page. I think, let me do some of these weirder ones. Let's write 87.5% as a fraction and a decimal. So I think writing it as a fraction is probably the easiest thing to do, because it's already in a fraction format. So this 87.5%, I would think of it as 87.5 times, so the 1% was equal to 1 over 100. And then what I'm going to do is convert this 87.5 to a fraction. Multiply 2 times 87, you get 174. Plus 1 is 175. So you get 175 over 2 times 1 over 100. And then I'm going to do some simplifying before I multiply it together. I noticed that 25 goes into 104 times, and 25 goes into 175 7 times. And so it looks to me like we get 7 over 2 times 1 over 4 which is 7/8. Now to convert that to a decimal, I could do long division here, or I could try to change all of this to a decimal. I don't think 1/2 requires a lot of effort on even the weakest type of student. So when I do this 1/2%, I'm going to change the 87.5 to 87.5. And then I'm going to change the percent to 0.01. Or I get rid of this. I was going to go like I showed you in the very first, but I think converting to the decimal percent first is a good idea, because now you're going to move the decimal 2 places to the left, and you end up with the 0.875. Next, let's convert a similar problem. Let's convert 6 2/3% to a fraction and a decimal. So we'll start with the fraction part. And I'll have 6 2/3 times 1/100. The 6 2/3, if I do 6 times 3, that'll be 18, plus 2 more will be 20. So I'll get 20/3 times 1/100. 20 goes into 100 5 times. So this looks like we have 1/15 as my fraction. Now as a decimal, you might find it difficult to move the decimal place to the left when you don't have a decimal to begin with. So what we'll do instead is 6 2/3 equals 20/3. And so what I'm going to do is convert that to a decimal. 3 goes into 20 6 times, and then I'll convert to a decimal and bring down a 0. 3 goes into 20 6 times again. And I think you see where this is going. I'm going to get 6's on forever and ever. So this is 6.6 bar percent. Now if I want to change that to a decimal, I will move this to the left 2 places, and we'll end up with 0.066 with the bar on it. And so this answer is actually correct. There's nothing wrong with it. I could circle it and hand it in. There's nothing wrong with it. However, it's not the most efficient way of writing this number. Here you're telling me the 6's are going on forever, but yet there's a 6 in front of it. So I could simplify this notation by simply doing this, dropping one of the 6's and putting a bar over the first one instead. All right, I think that's enough percentages to fractions and decimals. Let's move on to other kinds of computations. And this time, let's convert 0.59 to a percent and a fraction. So let's start with the percent. 0.59. To get it to be a percent, now to go to a decimal to a percent, we had to move to the left 2 places. So for this, if to go the other direction, we're going to go to the right 2 places. And so I'll get 59%. So I just moved the decimal place to the right. All right, then as a fraction, we have 0.59. That 9 is in the hundredths spot. So this equals 59 over 100. Next, let's convert 0.0672 to a fraction and a decimal. And a percent. In these, I don't see an advantage of doing one or the other first. Let me do the fraction first, just because it doesn't seem any more convenient. I'm just going to do it first because I wrote fraction first. All right, to convert to a fraction, you must know your place value names. So remember, after the decimal point, we have tenths, hundredths, thousandths, and 10,000ths. So that 2 there is in the 10,000ths position. So this as a fraction equals 672 over 10,000. Now, it's quite possible that you're going to be asked to write that into lowest terms. So for that, I don't see a fast way of doing anything other than if I divide the top by 4 and the bottom by 4, I'm going to get 2,500. But if I divide the numerator by 4, I'm going to get 168. So 168 over 2,500. Let me check that top one. 4 goes into 672 just to be safe. 4 goes into 6 once. 6 minus 4 is 2. 4 goes into 27 6 times. 24. Then I'll have 32 left, and then 4 will go into that 8 times. All right, so good. 165 over 2,500. Well, I can see that 4 is still going to go into these numbers. 4 will go into 168 again. Let's see, so 4 into 168. It goes into 16 4 times. Bring down the 8 twice. So I'm going to have a 42 there. And 4 into 6,500 is 625. So I get 42 divided by 625. Now 42, I know that 3 goes into 42, but if you add up the digits down here, 6 plus 2 is 8, plus 5 is 13. 3 doesn't go into 13, so 3 doesn't go into 625. There's not a lot that goes into there. 7 goes into 42. Obviously 2 does, but 2 doesn't go into 625. 7 goes into 42, but 7 does not go into 625. So I'm going to leave it like this. That's a fraction in lowest terms. Check with your instructor what format that they want you to leave the answer in. Now, for the percent, that's a lot easier. I'm going to take my 0.0672. Remember, when you're going from a percent, from a decimal to a percent, you go to the right 2 places. So I'm going to get 6.72%. Convert just the number 10 to a percent and a fraction. So the percent Well, let's assume we're already in decimal format. I'm going to move my decimal 2 places to the right. That means I'll end up with 1 with 1, 2, 3 zeros after it. That's 1000%. Now, as a fraction, I often hate these kind of problems because it's just 10 over 1 or itself. I think just writing it as 10 is not going to be a problem. Although, ask your instructor if they prefer 10 over 1 versus 10. Let's convert 1/10 to a decimal and a percent. Now, unless you know what the decimal is already, you'll probably have to use long division to figure it out. So let's start with the decimal. Once I get decimal, everything else is really simple to do. So for my decimal, I'm going to take 10 and I'm going to divide it into 1.0. And 10, of course, goes into 10 one time with a remainder of 0. So we get 0.1 as my answer for the decimal. Now, as a percent, we take the decimal and move it to the right 2 places. So it looks like I'm going to have a 1 with a 0 behind it, and I'll get 10%. Let's convert 1 over 25 to a decimal and a percent. So for the decimal, I'm going to do exactly what I did last time. In fact, anytime I'm converting a fraction to a decimal, I'm going to do the same thing. 25 will go into 1.0. 25 doesn't go into 1. 25 doesn't even go into 10, but it will go into 100. So notice I have a 0 waiting for me up there. 25 goes into 100 4 times with the remainder of 0. So the decimal version is 0.04. For the percent, we're going to take 0.04 and move our decimal to the right 2 places. So we'll end up with 4% or 4.0% should you want it to match the decimal more closely. Let's convert 3/8 to a decimal and percent. So to do the decimal, I'm going to do 8 into 3, well, 8 into 3.0. 8 goes into 30 a total of 3 times. 30 minus 24 is 6, and bring down a 0. 8 goes into 60 7 times. Add a 0, bring down a 0. 8 goes into 45 times. And that finally finishes that one off. So as a decimal, I get 0.375. Then as a percent, I'm going to take my 0.375 and move my decimal to the right 2 places, and I'll get 37.5%. That is the worst looking percentage sign I've ever seen. It looks like I smashed a spider on my screen. That doesn't look a lot better, but at least it resembles percent better. let's convert 13 over 16 to a decimal and percent. So let's start with the decimal. I'm going to do 16 goes into 13. Give yourself a lot of room. I usually do when I do long division. 16 doesn't go into 13, so I'll add a 0. 16 does go into 130. How many times? 9, let's see, 8. I think 8 times. 8 times 16 is 128. When I subtract, I have a 2. Now I'm permitted to bring down a 0. 16 goes into 20 one time. Add a 0, bring down a 0. 16, and increase this division bar as long as you need it. 16 goes into 40 twice. Add a 0, drop a 0. 16 goes into 80 exactly 5 times. And so there we have as the decimal 0.8125. Now as a percent, I take my 0.8125, move my decimal to the right 2 places, and I have 81.25%. Let's convert 3/40ths to a decimal and percent. Start with the decimal. We have 40 goes into 3.0. And notice 40 does not go into 30. It's not 30 is too small of a number for it to go in even once. So I have to put a 0 there. Add a 0. 40 goes into 307 times. Add a 0, bring it down. 40 goes into 205 times. So we have 0.075 is my decimal. For the percent, 0.075, move the decimal to the right 2 places, and you get 7.5%. Now, one thing your textbook talks about, I don't particularly like this topic, but there is one thing that your textbook does do, and I'll do it just simply because they do it, and you might find it useful as well. Just because I don't like it doesn't mean that it's not a perfectly valid technique for anything. So let me make a note. You can convert fractions to percents directly by using proportions. So that means I don't need to go to a decimal first and then convert. I can go immediately from a fraction to a percent. And one assumes you could do the opposite direction as well, directly. So let's take a look at what I'm talking about. I want to use a proportion to convert 1/3 to a percent. So what I'm trying to do is this. I'm trying to figure out 1/3 equals x over 100. Remember, x% equals x over 100. So if I want to figure out what percent 1/3 is, I simply write an equation like this. And then I'm going to cross multiply as normal. 3x equals 100. And then I'll divide by 3. And your answer is literally 100 over 3%. That is the answer. Unfortunately, I happen to know that your instructor is probably not going to like that version of the answer. Now, I can convert to a percent with a decimal in it, but since I'm dealing with fractions, I'm going to stick that way. And let me convert this instead to a mixed number. So 3 goes into 10 3 times. 3 goes into 10 3 times. And a remainder is left over of 1. I'm not going to go to decimals. What I'm going to do is then write this answer as 33 1/3%. Notice the 33 1/3, they're all there. So these are some of those weirder ones that had fractions involved with a percent. This will help you along those lines. So notice that if you were to write it as a percent with a decimal, you could do this. I'm not going to show the work for it, but you could write it like this. And you get the same thing. That 3 with a bar over it is the same as 1/3. Let's do another one. Use a proportion to write 7/12ths as a percent. So 7/12ths equals x%. This was my model for setting up the equation. Is the same as 7 over 12 equals x over 100. Cross multiply. 700 equals 12x. Divide by 12. I'm going to do like I did in the last problem, and I'm going to write it as a mixed number. So I'm going to do 12 into 700 and see how many times it goes in. Let's start with 12 goes into 70 5 times. Bring down a 0. 12 goes into 100 8 times. And then I did not want to go into decimals. So this is the same as 58 4/12. Hopefully you ought to know that that is the same as 58 1/3. So our answer is 58 1/3%. Or if you were a decimal kind of a person, that's 58.3 with a bar over it percent. Here's some of the questions I've noticed. Round that last answer to the nearest tenth. Interesting that they would want you to round something that I answered with a fraction. So anytime you're talking about a nearest tenth, you're talking about decimals. So I'm going to use this version of the answer. This 58.3 bar percent is the same as 58.3. Now it says to write it to the nearest tenth. That's this decimal right here. Let me circle it. That's the decimal I want to round to. The decimal after it tells me to round down. and we end up with 58.3%. So there's the rounded version of the answer. Let's use a proportion to write 7/6 as a percent. And as before, 7/6 equals x percent, or 7/6 equals x over 100. Cross multiply. 700 equals 6x. Divide by 6. And once again, that is the correct answer. 700/6% is correct, but I'm anticipating that instructors will require you to write it as a mixed number, so I'm going to do that. 6 goes into 7 one time. 6 goes into 10 one time. 6 goes into 40 6 times. And now I'll put my decimal and start bringing zeros down. 6 goes into 40, well, 6 times. I can see where this is going. I'm going to get 6's off forever. So, actually, you know what? Nah, what the heck? 116.6 bar percent. I was going to do a mixed number, but when I saw that I went to a decimal, I just ran with it, so we'll leave it like that. The next example is going to relate to the last one. Round that last answer to the nearest 10th. So this works out for this problem because that specifically talks about a decimal. I'm going to be looking at 116.6, and these 6's go on forever. So the 10th spot is circled. The digit after the 10th spot says to round up this time. So I'll have 116.7% will be my rounded answer.